Good morning, my dear JEE Advanced aspirants. For the year 2025, we have got to you the most amazing PYQ series where we pick up all the amazing PYQs unit wise, and you've already seen so many chapters or units are already done, and more questions to be solved in the days to come in the run up to your JEE Advanced 2025 examination. So, let's get started with the ray and wave optics for your JEE Advanced 2025. All the important questions which were repeated in the past couple of years, and these are very good concepts which you will learn today via these particular problems. Very different way of looking, very unique way, even though you will feel I know the formulas or I know the theory, but still you will find that there is a little bit of a struggle to approach the problem or to reach the end of the solution. So very unique questions for the JEE Advanced 2025. All the latest pattern, all the multiple choice, all the integer numeric type of questions, all of this will be done today. Good morning, H Perfect, Karthik, Alan, and I hope this timing is also cool because in the morning you guys are fresh, we can learn a lot of things, and throughout the day you can definitely practice a lot of questions, right? So let's begin, and I hope you have smashed the like button for this particular video. If you have not done that, please do that, yeah, because it takes a lot of trouble to make these questions, to find these questions, sorry, and to conduct these classes as well. And yes, please smash it, show your support, because I don't think anybody is doing it in English, first of all. Number two, we have been consistent throughout and giving you quality content. And if you want more such questions, use the Rank Accelerator book, which has non-PYQ questions, because PYQs though you will solve, but this non-PYQ questions for physics, chemistry, mathematics for 1665 with two levels, level 1, level 2, and every chapter has that segregation. Yeah, so very good questions, thousands of questions. If you practice this book with PYQs, your CET and IIT is guaranteed. So don't look for anything else. This book has been used again and again by our toppers. Okay, so let's begin. Now let's start with wave optics, then we'll go to ray optics. Okay, so let's go. How many marks to get below 20K? Elijah, maybe you can put up that doubt after the session is over. I'll definitely get back to you. Ragesh, hello. Please make a video on EC. Definitely, I will. I'll definitely consider that, Kavya. Okay. All right. Look at this question. This is a warm-up question. This was asked in JEE Advanced 12. Okay. Young's double slit experiment is carried out by green, red, and blue light, one color at a time. The fringe widths recorded are blah blah blah. Which fringe width is more? Which fringe width is less? This is just a warm-up question. This is not even a good question. I'm telling you now only. Okay. Let's see, guys. If you guys can figure this out, it's very simple. Come on, think about it. How are you going to solve this particular question? Yeah. Think, what are you going to do? See, fringe width. Oops. Fringe width in a Young's double slit experiment is lambda d by small d. Now we all know violet light deviates the most and red light deviates the least. So the refractive index and wavelength, everything are related to each other. Also lambda for violet is less as compared to lambda for green, and lambda for red is the highest. So same way, beta for violet will be the least as compared to beta for green, and beta for red will be the highest, because you can see fringe width is directly proportional to lambda. Yes, beta of violet will be the least. Beta of violet will be the least. Yes, beta for violet or blue, whatever. Blue is used. So blue will be the least, green, and then red. Yeah, perfect. Yes, red D option. Everybody got it correctly. Awesome, guys. Perfecto. Let's go to the next question coming up on your screen. Now onwards, the good questions have started. Okay, get ready for it. This is a good question. Take your time. A Young's double slit experiment, okay, in which slits S1 and S2 are immersed in liquid like water and air. But the funny part is, first slit is in air, the second slit is immersed in water. Can you see that? So there is a difference. Okay, just 1 second, guys. It's partially in water, partially in air. Okay. Now it is given the positions of the maxima on the interface is given by x. This x has a locus. p square m square lambda square minus d square. D is this half the distance between the slits, or 2d is the distance between the slits. Lambda is the wavelength. M, I think, is some integer, if I'm not wrong. Yes. We have to find what is this number p if x represents the positions of maximas. Okay. Let's try to do this. Everybody ready for it? Okay. So maybe I have just the slide with only the diagram. That will be better. Now, if you have to produce some kind of interference at a location x, what you have to do? Just take this particular ray, which is coming from S1. It is meeting here. And this particular ray, which is again meeting at this distance x. This is, let's say, point P. I will have to check the path difference and equate the path difference to some integral multiple of lambda. So if our, let me create a duplicate. Yeah. If our path difference is some integer times of lambda, then there is constructive interference. Then there is constructive interference at that location, at that location P. Now, what is this delta x, the path difference? Because the mediums are different, the optical paths are different. Yes, so think about it. The optical path lengths are different. This ray S1 to P is directly traveling through air. So the optical path length is just S1P. But this ray traveling to slit 2 is traveling through water. So the optical path length will be whatever is the distance S2P multiplied mu times. So that gives you the path difference, which is equal to m lambda. So the concept which has to be used over here, main concept is that optical path is mu times the geometrical path, mu times the geometrical path. So the geometrical path was S2P, the refractive index of water, whatever is it, it is mu. So mu times of that will give you the optical path, which is different because the light speed will be different, it will be slower. So obviously the effective distance will change. Is that right? Okay, Deva, don't spam. Whatever it is, I will read about BARC exam, whatever you want, and I will give you the details, okay, after the lecture is over, but not now, okay? Leave the comment after the video. Now, what is mu? Is the refractive index given to us? I think it is given to us somewhere. Yes, it is given to be 4 by 3. So let me put over here mu as 4 by 3 multiplied by what is S2P. It is the hypotenuse of this triangle. So I can just write it as root of d square plus x square minus what is S1P. It is also the hypotenuse of this triangle. So by Pythagoras, it is again root of d square plus x square is equal to m times of lambda. I can say root of d square plus x square is common. So 4 by 3 minus 1, common thing is root of d square plus x square is nothing but m times of lambda. 4 by 3 minus 1 is nothing but 1 by 3. So this times root of d square plus x square is m times of lambda. Take 3 on the other side. So root of d square plus x square is nothing but 3m times of lambda. Okay. Now square both sides. So I will get, therefore, d square plus x square is nothing but 9m square lambda square. And I think we wanted x square. So x square will be 9m square lambda square minus d square. Okay, now this is that part where we decide what should be the answer. See guys, the question says p square m square lambda square minus d square. So p square m square lambda square. So p square m square lambda square minus d square. So what will p be equal to? P will be obviously be equal to the number 3. P will be equal to the number 3. So I think 3 should be the answer. Yes, perfect. 3 is the right answer. Everyone understood? Very good, Raghu. Excelente. Awesome. Awesome. Very nice. Very nice. Let's go, guys. Let's go to the next question then, right? Okay. Perfect. So here comes the next question. Wow, this is also again a question with two different refractive indices. So that looks like the favorite question of the examiners, because obviously you are used to either having the complete medium changed or the complete medium is air. So that is not interesting in JEE Advanced. It will become complex only when the two mediums are different, and that too for two different slits. So look at it. In a double slit setup as shown in the figure, one of the slit is in medium number 2 and having a refractive index of n2. Other slit of refractive index is n1. Okay, so this one is in n1, this one is n2 refractive index. None of the refractive indices match. N1 is not equal to n2. The line joining the slits is perpendicular to the interface. Look at that. The line joining the slits is perpendicular to the interface, and the distance between the slits is given to be d, standard information. The slit widths are much smaller, okay, than d. Why is this given? The slit width is much smaller so that diffraction can occur and the light can spread everywhere so that the interference can occur. Okay, the slit widths are much smaller. Okay, a monochromatic parallel beam, as you can see, the parallel beam of light itself is falling at an angle, okay, and it is incident on the slit 1 in medium 1. Now a detector is placed in the second medium at some angle such that this angle equals to the angle of refraction. So here is the catch. This light which enters like this will get refracted. So imagine the light going like that and getting refracted. So this angle is exactly the angle of refraction at which you have placed the detector. Okay, so that is the condition extra which is given apart from n1 and n2 not being equal. Consider two approximately parallel rays received by the slits. So one ray on the slit 1, another ray on the slit 2, and then there are the multiple choice questions. Read the multiple choice questions. The phase difference between the two rays, one ray here and one ray, is independent of d. The two rays interfere constructively. The phase difference depends on n1 but not on n2. The phase difference vanishes for certain values of d and the angle of incidence of that particular refraction. So we do not know what might exactly happen. So best way is to make a general formula for your path difference. Is that right? Okay, so hopefully I just have the diagram. All right, so the diagram is there. All right, so we'll play with only the diagram. Just keep in mind, consider two parallel beams of light rays. Number one, n1, n2 are different. Second condition in your head. Third condition in your head, this theta after refraction is the angle of refraction. Okay, so let me consider two rays now. Let me basically consider two rays. Okay, so just imagine one of the ray is like this, one of the ray is, let's say, like this, and let's say it goes particularly like this. Okay, it goes like that, and another ray, let's say it comes in this particular manner, and before refraction it was like this. Okay, let me also draw perpendicular over here. Okay, perfect, this is good enough for me. And theta is the angle of refraction, so this is definitely theta, and this is also definitely theta. I don't think I will need this as of now. That's okay. This as of now is not needed. See, if this much is clear, my dear students, everybody with me? All right. Very good. Now, these two parallel rays, okay, so this particular rays which are there, okay, they are basically going to now interfere. They are basically now going to interfere. Let me just put it over here like this. They are going to come over here, and these two rays will fall on the detector and they will definitely interfere over here. So the detector is now going to be here. This is a narrow beam. Okay, this is just a narrow beam that is going to be detected over there. So let's try to find out the path difference. So to find out the path difference, I need some geometrical constructions. First construction, maybe draw perpendicular here. Second construction, maybe drop a perpendicular over here. And maybe third construction, drop a perpendicular over here. So maybe these things, or maybe that is not even needed. Okay, this much is enough, I feel. Okay, let me start marking these numbers over here. So let me call this, let's say A, let me call this B, let me call this C, let me call this D. Okay, and let me call this as E. Okay, so I have just marked all these points right over here. Now, quickly think and tell me what will be exactly the path difference. Quickly think and tell me what will be exactly the path difference. Okay, quickly think and tell me what exactly will be the path difference, guys. Yes, this particular rays till this point C and A were together. After this, this ray had to travel CB and B. This ray had to only travel AD because after D and E, both of them travel together. Okay, so delta x will be this path minus this path. So it will be optical path of CB plus optical path of BE minus optical path of AD. Now these are the geometrical lengths. I have to carefully multiply it with their corresponding refractive indices to convert it into optical path. Yes, to convert it into basically optical path. Observe carefully. Observe carefully. CB is in refractive index 1, so I will multiply it with N1. BE is in second refractive index, so I will multiply it with N2. A to D is in second refractive index, so I'll multiply it with N2 again. I'll multiply it with N2 again. Okay. Now what is CB? CB, if you see in this small triangle, C to B, in this particular small triangle CB over here, this is A, this is basically X. Over here, this is basically your angle of incidence. CB is basically the opposite side. So sine of I will be CB divided by your hypotenuse. So CB will be X sine of I. CB will be nothing but X sine of I. And this particular N1 will stay over here as it is. Plus, what is BE? Before multiplying with N2, what is BE? BE is right over here. BE is right over here. So, okay, so going like this is 90 degree. This is B, this is E. Okay, this is D, this is small d. This is basically your theta. So I can use again cos theta relationship. BE is adjacent to theta. So cos theta is nothing but BE adjacent by your hypotenuse, which is D. So BE will be nothing but D cos theta. So this is nothing but D cos theta. Okay, minus AD. Minus AD. So before that, multiply it with N2. What is this distance AD? So look at this particular triangle over here. Look at this particular triangle over here. This is A, this is B, this is D, this is X, this is D, and obviously this is nothing but theta. Sorry, this is nothing but theta. So if you want AD, I think we can use cos theta. So cos of theta. So cos of theta will be nothing but d divided by AD. D divided by AD. So A to D. So A to D will be nothing but d divided by cos of theta. D divided by cos of theta. Can you see that? D divided by cos of theta. Everyone with me? Yes, perfecto. Till this point, absolutely clear? Yep. Okay. So just put over here as it is, A to D will be nothing but D divided by cos of theta. Now is it fine? Everyone give me a thumbs up quickly. Perfect. Okay. Now we'll start solving. Now there is no problem. Just that this x is also remaining. This x you can see from tan theta being x by d. So x will be d tan theta. So this x will be nothing but d tan of theta. Okay. So we'll rewrite this as d tan theta multiplied by n1 sine I1 or n1 sine I plus n2 d cos theta minus n2 d by cos theta. But wait a minute, n1 sine I by Snell's law, by Snell's law, by Snell's law, n1 sine I will be n2 sine R or n2 sine angle of refraction. So N1 sine I1 will be N2 sine I2 is equal to N3 sine I3. That is how Snell's law works. So that is why this d tan theta multiplied by N2 sine theta plus N2 d cos theta minus N2 d by cos theta. Perfect. So I can see N2 and d as common, N2 and d as common. So let me take N2 and d as common. So I'm left with tan theta multiplied by sine theta plus cos theta minus 1 by cos of theta. Okay, so what will this be? N2d, I can take cos theta in the denominator as common, cos theta as common. So tan into sine into cos. So tan theta into sine theta into cos theta plus cos square theta minus 1. Now, what is this going to be? Tan theta into sine theta into cos theta. Tan is sine by cos. Cos will cancel. So this will become nothing but sine square theta. So this will become nothing but N2d by cos theta. This is sine square. This is sine square theta plus this is cos square theta plus cos square theta. This is nothing but minus 1. Sine square plus cos square is 1. So 1 minus 1 is 0. So if it is 0, it just means the part difference, no matter what you do, is 0. So it is definitely going to be a constructive interference. So it is definitely going to be a constructive interference. So it is coming out to be independent of anything like theta, like even the d, even n1 or even n2, nothing it is dependent on. Are you able to see that, my dear students? Yes, it is not dependent on anything. So hence the correct answer will be phase difference is independent of d. Yep, the two rays interfere constructively. Perfect. Phase difference depends on n1. This is definitely wrong. This is definitely wrong. The phase difference vanishes only for certain values. Only for certain values. Wrong. It is independent of d, first of all. So hence only A and B will be correct. Hence only A and B will be correct. So this is the logic for this particular question. Beautiful. Yep. Okay. Clear. So the concept of optical path had to be used very, very carefully. If you miss up, CB was in medium 1, B was in medium 2, A to D was in medium 2 again, then you will get completely wrong answer. So again, here we have used the concept of optical path, optical path concept, which is mu times of your geometrical path. That is what we have done over here. Cool. Shall we go ahead to the next question coming up on your screen? Okay. Here comes the next question. There are two coherent monochromatic point sources, S1 and S2. Okay. Wavelength is 600 nanometer. Wavelength is 600 nanometers are placed symmetrically on the either side of the center of the circle, separated by a distance of this d 1.8 millimeters. The arrangement produces interference fringes visible as alternate bright and dark spots on the circumference of the circle. Okay, the angular separation between consecutive bright spots is delta theta. Which of the following options are correct? The angular separation between the bright spots decreases as we move from P1 to P2. Okay. At P2, the order of fringe will be maximum. That is at this point they are mentioning. Then a dark spot will be formed at P2. That means over here. So either it is bright or dark. We have to figure that out. Total number of fringes between P1 and P2 is around 3000. That's what they are saying. Okay. Fine. Let's see. What do we do? First, let me just see if I have only the diagram. Yes, I have only the diagram. Okay. Now, in these type of questions, I'll tell you what exactly happens in these type of questions. Remember the theory that the locus of all the points where the phase difference is constant is a hyperbola. I'll remind you, whenever you find the locus of all the points with path difference as constant, that is basically hyperbola. And that is how hyperbolas work. The distance, the difference of the distance between two fixed points, if it is constant, then it is called as a hyperbola. That's how it is. S1p minus S2p is equal to m times of lambda. So if this difference of distances between two fixed points is constant, then it is basically a hyperbola. So how the hyperbolas go is something like this. You will probably have one dark fringe here, then another dark fringe like this, another dark fringe like this, another dark fringe like this. So this is how the hyperbolas will look like. And in between that, you will have the bright fringes also, whose hyperbolas will be something like this. So this is how the hyperbolas are going to look like. Is this absolutely clear? This is the locus of all the points where the path difference is constant. So anywhere on the blue line, you will find a bright spot. Anywhere on the pink line, you will find a dark spot. Anywhere on the blue line, again a bright spot. But the order of interference will be different. Okay? The order of interference will definitely be a different value. Now, let's start with the first option. What does it say? It says that the angular separation between two bright spots decreases as we go from P1 to P2. So as you can see, as we move from one point to the other, so the path difference keeps on changing. So maybe even the distance between those two fringes might definitely change. Yeah. So here is an idea. Here is an idea. See, the two slits are over here. One is S1, one is S2. One is S2. The distance between them is basically D. If I draw a line like this, and you are essentially considering this particular circle like that, okay? If you go at, let's say, any point over here, this is some random point. Let's say this is angle theta. And now, if you try to measure what is the path difference for the rays which are coming and meeting over here, well, this is like your Young's double slit experiment. This is like your Young's double slit experiment. And the path difference will be just obtained by drawing a perpendicular. So this particular length will be your delta x. So our delta x at any point P will be nothing but d sine theta or cos theta. Let's see, if this is theta, then check this out. This will be also theta, then this will be also theta. Everyone with me? Yep. Yes. So this will be theta. Yes, this will be also going to be theta. So this is opposite. This is opposite to theta. So yes, d sine theta only. So d sine theta. Okay. So that is what this is. Now let's think. If I want the angular fringe width, that is what the first option says. The angular separation between two bright spots decreases as we move from one point to the other. Okay, that is what they have asked. So how about differentiating this? Because I am interested in the angular fringe width, meaning the difference of the angular positions. So if I'm interested in the difference of the angular positions, which gives me the angular fringe width, so I must be interested in the derivative of this. So what I will do is take the derivative of delta xp with respect to theta. This will be nothing but d derivative of sine of theta. The derivative of sine of theta is nothing but cos of theta. So now once we have taken the derivative, over here, so this is nothing but d delta xp by d theta. So therefore d delta xp will be d cos theta into d theta. Now think like this. D theta over here gives me the separation, angular fringe width, or the angle between two fringes, angular fringe width. Okay. This particular thing, the path difference from one fringe to the next fringe, from one fringe bright to the next fringe will always be lambda. If you are considering consecutive fringes, this particular thing, won't it be lambda, guys? Won't it be lambda? Because you are looking from one fringe to the next fringe. Always the path difference will change by lambda, 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 always. Whether it is from 3 lambda by 2 to 5 lambda by 2, 5 lambda by 2 to 7 lambda by 2, or from 7 lambda to 8 lambda to 9 lambda to 10 lambda, like that. So this left hand side is a constant, d is a constant. So from this, what we get is cos theta into d theta is basically a constant, or if you don't like that constant word, it is nothing but lambda divided by d. So therefore d theta will be lambda by d, and you have cos theta over here. So if you go from this point to this point, which are those points? From point P1 to point P2. If you are going from point P1, the point P1 is here, point P2 is here. What will happen to theta? Theta will obviously increase. If theta increases, what will happen to cos theta? Cos theta will obviously decrease. If cos theta decreases, the denominator decreases, the ratio increases. So d theta will basically increase. So what should happen to the fringe width? This d theta is your angular fringe width, angular fringe width. Obviously it should increase. So let's see, what does it say? The angular fringe width decreases as we go. Oh, that is definitely wrong. So this is wrong. It should have been increases. It should definitely have been increases. So A option is wrong. Everyone, till this point, absolutely clear? Give me a thumbs up. Yep. Everybody with me? Beautiful concept till this point. Okay. Now let's go to the next option. At point P2, what exactly do you get? At point P2, what exactly do you get? So at P2, if you want to see what exactly you get, one ray will go directly like this, the other ray will go like this. So there is definitely a path difference at P2. So delta x at point 2 will be S1 P2 minus S2 P2, which is nothing but this distance minus this distance, which is nothing but S1, S2, which is nothing but D. Now here is the catch. Let's see how much that D is. D is how much? D is how much? D is how much? Somewhere it is given. Yeah, it is 1.8 millimeters. So D is nothing but 1.8 millimeters, which is 1.8 into 10 to the power minus 3 meters. Now see, how many times is this as compared to lambda? So always, whenever you get the part difference, just see what is that number as compared to lambda. Okay, just always find that part difference with respect to lambda. So it will be 1.8 10 to the power minus 3. The wavelength was also given. The wavelength was, where is it? Wavelength was also given somewhere 600 nanometers. Wavelength was 600 nanometers. So just put 600 into 10 to the power minus 9. So this will become 1800 into 10 to the power minus 6 divided by 600 into 10 to the power minus 9. So that will be equal to 3 za. So 3 into 10 to the power 3, which is basically 3000. So that means at point P2, the part difference is 3000 lambda. 3000 is an integer, and whenever you have an integer, it means it is a constructive interference. It is nothing but a constructive interference. That means that particular spot will be bright. That particular spot will be bright. So the order of the fringe will be maximum. The dark spot, no, definitely. The order of the fringe will be maximum. Yes, this is definitely correct. Maxima or bright or constructive, everything is the same thing. Is that correct, everyone? Okay. Now, I think there is one last option left, which is that D option. The total number of fringes produced between P1 and P2 is 3000. That is obvious now. I'll show you over here. When the two rays will meet at P1, they both arrive simultaneously. The path difference at P1 will be 0 because this is congruent to this. Somewhere in after P1, the path difference will be 1 lambda. then it will be 2 lambda, then it will be 3 lambda. Like that, if you continue over here, finally the part difference at P2 is basically 3000 lambda, isn't it? From P1, which had 0 lambda, to P2, which we just found out, it is 3000 lambda. The part difference is coming out to be 3000 lambda. So there are approximately how much? 3000, approximately how much? 3000 fringes that you have, 3000 fringes that you have from point P1 to P2, from point P1 to point P2. Hence, this option, the number of fringes between P1 and P2 is 3000. Definitely, this is a correct option. So I think B and D should be the right answer. Let's find out. Yes, B and D are the right answers. Is this wonderful question? Did you like it? Yeah. Okay. Okay. Luke, uh, can I did not qualify for James. Can you, Luke, can you do one thing? Can you please put up all these comments related to counseling after the class? Because if you ask, one more person has also asked another person. I know a lot of queries are there. I will try to make videos on all of these comments. So I have read all your comments on the previous videos. There were around 800 comments in just the previous video, and even the video before that had some crazy comments. So I have read all your comments, and I'm working tirelessly to make videos for you. So although we have started making many videos regarding counseling, JOSA, NITs, triple ITs, everything for BITS, COMEDK, and private and colleges in Andhra, in Telangana, in Karnataka, in Kerala, in Tamil Nadu, all these colleges will be making videos. Don't worry. Okay, definitely. All right. For 11th portion, VIT Triple E, please check my older videos, Varsha. That will be helpful. It's there on the channel. Okay, it's there on the channel. Look at this particular question. While conducting the Young's double slit experiment, a student replaced the two slits with large plate, opaque means it is not transparent, in the XY plane. XY plane is horizontal plane. This is coming towards you is x-axis, that is y-axis, z-axis is on the top. Okay, there are two holes over here. They act like coherent sources. So the wavefronts are going in all the directions on the upper side. Okay, the wavelength of the light is 600 nanometers. The student mistakenly has placed the screen in the zx plane. Z more than 0 means on the top, z less than 0 would be below. So in the zx plane, so zx plane is basically the plane towards you. So think as if there are two sources over here and zx plane is over here. So this is acting like a screen now. Okay, so the distance between the sources is also given. The origin O is at the intersection of all the axes. Okay, fine. The question is, which of the following is true regarding the intensity? Semicircular bright and dark bands centered at O. The region very close to point O will be dark. Straight bright dark bands are parallel to x-axis. Hyperbolic bright and dark bands with foci symmetrically placed about O on the x direction. Okay, do I have just the diagram? That will be very useful. So first is regarding the shape. Just some time back I had told you about this. The locus of all the points where the path difference is constant is a hyperbola. I just had told you about it. Remember, everyone? Correct. Now use that concept right over here. I'll tell you how. If these are the two slits which are acting like the coherent sources, you will find alternate bright and dark bands, alternate bright and dark locus where it will look like hyperbolas. Yes, so maybe one hyperbola will be like this, another hyperbola will be like this, next hyperbola will be like this. Same thing will continue here also, but I'm not interested on this side because nothing is there on this side. So why bother? There is no screen over here. Here it will go like this. Now you have to visualize this in 3 dimension, my dear students. Now you have to visualize this in 3 dimension. Meaning, this is now the axis of the hyperbola. Just visualize this. Just visualize this for once. This is the axis of the hyperbola. You take any hyperbola for that matter. Let's say this particular hyperbola. Okay. This axis, if you rotate that hyperbola, or about this axis, if you rotate that hyperbola, that will basically become a hyperboloid. That will basically become nothing but a hyperboloid. Very, very important term that I'm using over here. Just visualize this. Just rotate it in this particular manner. Are you able to visualize this, my dear students? This is now a hyperboloid. These are basically hyperbolas in one plane. In a single plane, it is a hyperbola. If you rotate that hyperbola, it becomes a hyperboloid. It's a three-dimensional figure. So as you can see that in the XZ plane, what is it cutting like? When it is cutting, what is it cutting like? It is cutting like a circle. It is cutting like a circle in the XZ plane. So which is basically the screen. So all these hyperbolas, when rotated, becomes hyperboloids. When they actually end up cutting the screen, they cut it like circles. So you will have a bright circle, a dark circle, again a bright circle, again a dark circle. So if you observe the screen, which is basically your what is it, zx plane. So this is z plane, this is, let's say, x plane. What you are going to see is something like this. What you are going to see is basically something like this: a bright, then a dark. Yeah, something like that. Bright and then a dark, like this. Then again you will see maybe a bright like this, right? And then again something dark like this. This is what you are going to see. Concentric circles. This is what you are going to see on the screen. Is this understood? So now coming back to the question, semicircular. Why will it be semicircle? Because this part is opaque. It is not transparent. That is very important. So semicircles will be formed on the screen, because you can think as if over here only this much part of the screen was there. This much part will be obviously opaque. This much part will obviously be opaque. So this is not going to be seen. This is not going to be seen. This is not going to be seen. Only this much part is z more than 0. This much part is z less than 0. And it was mentioned, if I'm not wrong, somewhere here, z is more than 0. You have to only consider the upper part. So what will it look like? These are looking like semicircles. So hence, can I just directly mention that option A is correct? The option A is correct. Everyone with me? Bright dark bands are parallel to the x-axis? No, they are definitely not bands. Bands are not going to be formed. These are circular arcs which are going to be formed. Hyperbolic bright and dark bands with the foci symmetrically, no, it is not hyperbola. See, this word hyperbola is confusing. See, when you see the bands or whatever the fringes on the screen, they are circular. The intersection of those hyperbolas or the hyperboloids on the plane is not a hyperbola, it is a circle. So hyperbolic bright and dark bands are formed? No, that is also definitely going to be wrong. Yeah, it is circular. Is this clear? C and D options got eliminated. Is this clear? Give me a thumbs up, my dear students. Let me know quickly in the chat box if this much part you have understood. Then I will proceed ahead. Clear? Okay, very good. Yep. So C and D got eliminated, only A is correct. And the explanation for that I have given you right over here. These are not hyperbolas, their intersections are circles. If the option was the locus of the points where the path difference is constant is a hyperbola, then you would have marked this option, the locus of the points where path difference is constant. But that is not what is given. Now the last part is where what is at O. What is at O? So if you want to look what is going to happen at O, just look at these two rays. One ray is here, one ray is here. Both of them will reach here like this. So they will definitely have some path difference. So the path, the the path difference at O will be S1O minus S2O. S1O minus S2O will be nothing but S1 S2, which is nothing but S1, S2, which is nothing but just D. And how much is D? I think that is already given. 0.6003. 0.6003 millimeters. Don't say, sir, ignore that 3. Maybe that has some value, some significance. Now, like I have told you before, just think, now think, how much multiple is this delta x as compared to lambda? So it is 0.6003 millimeters is 10 to the power minus 3 divided by lambda. Wavelength is 600 nanometers. Okay, so divided by 600 nano is 10 to the power minus 9. So this will become 1, 2, 3 if I shift it. Okay, uh, 0.3 multiplied by 10 to the power minus 6 divided by 600 multiplied by 10 to the power minus 9. So this will become, yeah, just check it out, correct only, right? So this will become, so anyways, we'll see what will happen. 10 to the power 3, this will become 1 point, this is 30, 0, 0, 0, and 5. Yes, just check this. I think because this is 0.5, what we can do is delta x is 1000.5 times of lambda. Now, whenever your path difference is 0.5 lambda, 1.5 lambda, 2.5 lambda, in general, an odd multiple by 2 lambda, then it is basically a destructive interference. It is basically a dark region. Basically, it is a minima which is formed intensity wise. So as you can see, this is a 0.5. As you can see, this is basically a 0.5. Is that right? So if it is a 0.5, definitely then over here there should be a dark region. So let me see over here. Yes, where is it? The region very close to the point O will be basically dark. Yes, definitely this B option is the right answer. B option is the right answer. So definitely at this particular point, that region will be dark because of this particular calculation. Okay, is that right? Tintu, I will make counseling videos separately, don't worry. Yeah, the region very close to the point O will be dark. Alternate bright and dark semicircular rings are formed. Straight bands are not formed. Hyperbolic bands are also not formed. Perfect. That is also correct. Let's go to some ray optics questions. Are you ready for ray optics, my dear students? Okay. Let's go for ray optics questions. Ready for it, my dear students? Okay. Let's go. Here comes the questions. Monochromatic light wave is incident normally on a glass slab of certain thickness d. The refractive index of the slab increases linearly from n1 to n2 over the height h, for which of the following statements about the light which is coming out of the slab is true. Okay, so when this light enters the slab, here the refractive index is less, here the refractive index is more. So what happens is that wherever the refractive index is more, the light will be slower. Here the light is faster, so it will come out fast. So by the time the light comes out, you will see these rays will be ahead, these rays will be little bit behind. So there will be some lag, or somebody will be ahead of the other rays. That's what will happen. Okay, so it will deflect, it will deflect, it will not deflect. The deflection angle depends on n2 minus n1 and not on the individual values. Okay, so everything is about deflection and everything. So let's try to understand it. Look at it via wavefronts, then it will be easier. If you look at it via wavefronts, right, things will go easier. See, this is a parallel beam of light. So the wavefronts will look something like this. These are the wavefronts. This wavefront will enter till here. So this is nothing but planar wave fronts. The planar wave fronts, they are moving like this. Wherever it is slow, it will take some time to come out. Wherever refractive index is less, it will come out faster. So probably you will see this this ray reaching almost till here, this ray maybe till here, this ray maybe just till here, this ray maybe just here, and this ray maybe has just reached the tip. After this, the speeds will be same. So as you can see, there is a new wavefront which is formed like this. Can you see there is a new wavefront which has been formed like this, and that new wavefront of light will propagate in this particular direction. Yes, it will now propagate in this particular direction. It will now propagate in this particular direction. So the rays of light which will be coming out eventually, they will go like this, guys. They will not exactly go like that. So you will probably see the rays going like this. So definitely it has deflected by some amount. Definitely it has deflected by some amount. Can you see that? So I think there was an option saying it will not deflect. So 100% this option C is wrong. Everyone with me on this? This option definitely is wrong. Now, the questions or the options are, what is the deflection and what does it depend or not depend on? Okay. So to check that out, I have an idea. See, consider that ray which is going here versus which is going here. There is some path difference between them. There is some path difference between them. That is what will give me, that is what will give me the deflection eventually. See, the ray number 1 is traveling in a refractive index n1. So the optical path which we have discussed before is refractive index multiplied by the distance, the geometrical distance that is there. So for ray number 1, the optical path, the optical length will be nothing but n2 multiplied by d. For ray number 2, the optical length will be n1 multiplied by d. So the optical path difference will be nothing but n2d minus n1d. Taking d common, it is nothing but n2 minus n1, which also means that had this glass slab not been there, what it means, optical path, this particular ray number 2 would have traveled this distance, which is nothing but how much? N2d. This particular ray would have traveled slightly more distance. It is, let's say, n1 times of d, whatever. Okay, you can just take it like that. So now, do you see that these two rays are now making some angle over here? Do you see these two rays are now making some angle over here like this? And finally, we know our rays are going to come out like this, like this. So it is deflected. So if I draw a right angled triangle over here, if I draw a right angled triangle over here, this is height h. This one over here, this particular base is exactly the delta L. This particular base is exactly the delta L, which is d into how much? N2 minus N1. D into N2 minus N1. That is what that is. So if you want to find how much has it deflected by, if you want to find how much has it deflected by delta, if that is delta, obviously even this is nothing but delta. If that is delta, then even this angle over here is delta. Now you can just take tan of delta is opposite side by adjacent, which is nothing but delta L divided by H. So therefore, tan of delta is nothing but d times of n2 minus n1 divided by h. I think some tan was there somewhere. Oh, tan inverse was there. I can see that. So therefore, delta is tan inverse of d into n2 minus n1 upon h. So now observe this. Tan inverse of n2 minus n1 d by h. Yes, this is correct. It will deflect by n2 square minus n1 square. Wrong. The deflection depends on the difference and not on the individual values. Correct. Whatever is the difference matters. What if n2 is more, if n1 is also more, if the difference is the same, that's what matters to us, not just the individual values. So yes, D option is also correct. So B and D are the right answers. So B and D are the right answers. Let's check them out. Yes, B and D are the correct answers. Is this absolutely clear, everyone? Very good. Excellent. Perfect. Shall we go ahead to the next question, my dear students? Shall we go ahead to the next question coming up on your screen? Okay, let's see. What is it? There is an extended object which is placed at point O 10 centimeters in front of this lens, and another concave lens is placed 10 centimeters to the behind it. The radii of the curvature are 20, refractive index is 1.5, total magnification of the lens system. Okay, I just need the diagram, and the questions options are right over here. What is the magnification of the lens system? Do I have just the diagram? No, I don't have the diagram. So let me just do it over here. Okay, so read the question again. There are two lenses back to back, guys. Yes, there are two lenses back to back, and you have to find the effective magnification. What we need to do? We need to find individual magnifications and then multiply the magnifications m1 into m2. To find the magnifications, we need the image distances. Yes, we need the image distances. To find the image distances, let's use the lens formula. So starting off for this particular lens L1, if I use 1 by V1 minus 1 by U1 is equal to 1 by F1. I need the focal length first. So curved surface refraction is given and refractive index is given. So 1 by F1 is mu minus 1, lens maker formula, 1 by R1 minus 1 by R2. So 1 by F1 is equal to mu is 1.5 minus 1. Radius of curvature is 20. So 1 by 20 minus 1 by minus 20 because of the sign convention. If the rays are going like this will be the negative side. This will be the positive side. This is the first surface whose center of curvature will be on the positive side. The second surface will have a center of curvature over here. Okay, so this will become 1.5 minus 1 is 0.5 and minus minus will become plus. So 2 by 20, 2 into 0.5 is 1. So it will become 1 by 20. So 1 by f is 1 by 20. So I think I will use it directly over here as 1 by 20 and 1 by v1 minus object distance. It is at 10 centimeters, so minus 10. So therefore 1 by v1 will be 1 by 20. Minus minus is plus. On the other side again becomes minus. So LCM is 20. 1 minus 2, which is nothing but minus 1 by 20. That is 1 by v1. So therefore v1 will be nothing but minus 20 centimeters. Did you understand it? v1 is nothing but minus 20 centimeters. Everybody till this particular point clear? Absolutely. Okay, but don't stop over here. You have to also find the magnification. So what will be magnification 1, which is V by U. V by U. V is minus 20. U is minus 10. So it will be basically 2. So M1, we have got it as 2. M1, we have got it as 2. Perfect. Everyone, till this point, fine? Kumar, don't spam over here. You will be blocked. Unnecessary people are not going to be entertained on the channel. Please remember that. Okay. Yeah. So if you are going to do time pass, you are just going to get blocked on the channel. All right. This is a very serious channel, guys. Please understand that. Now let's go to lens number 2. Now for lens number 2, what will happen? The object will not be here. It will now be something else. Yes, this distance will change. Now the older object, the previous object, image, that image will now become the new object. Yeah, the image will now become the object for this, and this will be at a distance of 20 centimeters. So the image is formed here. So now this distance will be basically 20 centimeters. So now it has now become the object for the lens number 2, but from here. So this is the lens which has been considered now, L2. So the total object distance will be 20 plus 10, which is basically 30 centimeters. Everything has to be measured from the concave lens, correct? Yeah. So this image which is there now will become the object for the next lens. Yeah. Till this point, fine. First, find the focal length. 1 by f2 will be refractive index minus 1. 1 by 1 by minus 20 minus 1 by plus 20 by the sign convention, because the light rays will come from here. This will be the negative side. This will be the positive side. This is the first surface, center of curvature 1 will be here. This is the second surface, center of curvature 2 will be positive. Okay, so this will become 0.5 multiplied by minus minus 2 times. So 2 times minus 20. So this will be minus 1 by 20 is the second focal length reciprocal. Now let's do 1 by V2 minus 1 by U2 is equal to 1 by F2. So 1 by image distance minus object distance is 30 centimeter with a negative sign is equal to 1 by F2. F2 is minus 1 by 20. Okay, so 1 by V2 will be minus 1 by 20. Minus minus plus goes on the other side, again becomes minus. Take the LCM, which is 60. This will be 3 plus 2. So this will become minus 5 by 60, which is minus 1 by 12. So therefore, V2 will be nothing but minus 12 centimeters. So we have found V2 also, which is minus 12. Now you find the second magnification, which is V2 by U2. V2 is minus 12. U2 is basically minus 30. So this will be 12 by 30 divided by 3. It will be 4 divided by 3. It will be 10. So 4 by 10. So this will be nothing but 4 by 10. Till this point, absolutely clear? Yep. Very good. If you want, yeah, you can write it as 2 by 5 also. No issues. Yeah, you can write it as 2 by 5 also. Now, that is not the question. The question is total magnification. So let's come back to the original question. So our total magnification will be magnification 1 into magnification 2. What was the first magnification? First magnification was just the number 2. First magnification was just the number 2. What was the second magnification? Second magnification was 2 by 5. So it was 2 by 5. So hence, what is the total magnification? It will be just the product of this, which is nothing but 4 by 5. 4 by 5 is nothing but 0.8. Yep, 4 by 5 is nothing but 0.8. That should be the right answer. Yes, it is the right answer. So quite lengthy question, but that is why it is an advanced question. You have to do so many things. Chances of making silly mistakes are there. Plus, when you find the image in the first situation, you might forget to take the distances from the second lens, and you might by mistake measure all the distances from the original convex lens. So all these chances of silly mistakes are there. Is that clear, my dear students? Shall we go ahead to the next question coming up on your screen? Okay. Memory based VIT triple E is very difficult, man, because number of questions are heavy and students are also scattered. Little difficult to do it. I mean, you can do it, but it's very, people first of all don't respond to the form links. That is the problem. We had tried it. I mean, at least in JEE people respond, but in VIT triple E very difficult. So I find it very strange why students don't want to help others. I mean, like just imagine, even if it was your shift, I think you should be the ones saying, okay, fine, I'll give the memory based questions, so what? But like we have seen a lot of pullback or withdrawal for such things from many students. Anyways, if it happens, then we could have been able to conduct it. Moving on to the next question on your screen. There is a small object which is placed at 50 centimeters to the left of a thin convex lens of a focal length, whatever. Convex spherical mirror of radius of curvature 100 is placed to the right at a distance of 50 centimeters from the convex lens, but the mirror is tilted by 30 degrees. The question is, if the origin of the coordinate system is taken to be the center of the lens, that means this is the origin, this is y-axis, this is x-axis. So the coordinates of the point where the image is going to be formed is where exactly? Beautiful question, guys. Observe it carefully. Observe it carefully now, what we are going to do in this particular question. JEE Mains result, are they correct or wrong? Whatever it is, we have to accept it now, because now is not the time to fight. Where the other exams are there. Let's focus on that. Obviously, the results are, I would say, definitely doubtful. They are very, very uh, ambiguous, and they are questionable. There is no clear clarity and special injustice to shift one students, and also 4th April, and also many students from other shifts also had a lot of bonus questions which were not considered or they were not dropped. So is the result fair? Maybe not. But can we do anything about it? Yes. Should we do it now? Maybe. But there are other things. Will we get justice? Maybe not. So is it worth the time? Maybe not now, considering so many other exams. But 100% you should raise the voice. You should tweet about it. You should talk about it. You should let your juniors know. You should tag, tweet, put it on social media so that at least the NTA is under pressure and your juniors don't suffer. Yeah. Okay. Let's go to this question solution. The question is, what are the coordinates of the final image formed? Okay, I just need one diagram. My God, diagram is only not there. Okay, just see the question. Maybe you can start doing the lens part initially. Okay, the lens part you can start doing it. Because obviously first thing that you will do is find where the image of the lens will be formed. Okay, observe now carefully. This particular lens will form an image given by 1 by V minus 1 by U is equal to 1 by F. Image distance I don't know. Object distance is negative 50. Focal length is 30. Okay. So 1 by V is equal to 1 by 30. This goes as minus 1 by 50 because minus minus is plus, goes on the other side, becomes again negative. Is that right? Okay. Perfect. Let's see what is the answer to this. So 1 by V is equal to, the LCM will be what, 150, I believe, 150. Yeah. So this will go 5 times, this will go 3 times. So this will be 2 divided by 150. So that will be 1 divided by 75, but that is 1 by V. So image distance will be 75 centimeters. I have not even considered the mirror as of now. Just forget it. Just think where the image will be formed. The image will be formed at 75 centimeters. So somewhere over here. So this is where the image is formed. So this particular distance will be obviously 25 centimeters because this total distance was 75 centimeters from here to here. I'll tell you what, just for a moment, forget that the mirror was tilted because I noticed one interesting thing right now. This was 75 centimeters. Okay. Everyone till this point absolutely clear? Okay. Very good. Now, what about this? If this mirror was not at all tilted, just imagine that for a moment. Just imagine this for a moment, that the mirror is not at all tilted. So all these things are not there. Imagine this mirror is not at all tilted. All you have now is this curved mirror like this. Okay, you have this curved mirror over here. Okay, you have this principal axis like over here, and the rays coming from the lens, they are essentially trying to form the image somewhere over here. They're trying to form the image somewhere over here, and that distance from here to here is obviously 25 centimeters because the total image distance from the lens is 75 centimeters. So this is where the image is going to be formed. But that image will act like an object for the mirror. That image will act like an object for the mirror. So this image will now become a virtual object for the convex mirror. For the convex mirror. Is that right? That was a convex mirror. Perfect. And what will it do? What will it do? It will make an image on the other side. It will basically make an image on the other side. Okay. So where will it form the image? Let's try to figure it out. So using mirror formula, using mirror formula, 1 by V plus 1 by U is 1 by F. I think the radius of curvature was given to this. Radius of curvature was 100. So R is basically 2F. 100 is basically 2F. So F is basically 50 centimeters for this particular mirror. So this is 1 by 50 positive because it's a convex mirror. Object distance is plus 25. So 1 by V is 1 by 50 minus 1 by 25. Observe this now. So therefore 1 by V is equal to LCM is 50. So 1 minus 2 is equal to minus 1 by 50. So the image distance is negative 50 centimeters. What does this mean? Image distance is negative 50 centimeters means the rays are reflecting back and forming the image exactly at the center of that lens. So this is where your final image is formed exactly at a distance of 50 centimeters. Oh, so that is what is happening. Now what to do? Now what to do? This mirror, had it been not rotated, the image would have been formed over here. But now, since you're rotating it, what will happen? Since you're rotating it, what will happen? This image will go somewhere else. This image will go somewhere else. Where will it go, guys? It will go basically somewhere over here. And if you rotate the mirror by theta, the image gets rotated by an angle of 2 theta, if you remember this correctly. Yes, the image will rotate by an angle of 2 theta, 2 theta, definitely, and this is nothing but 50 centimeters. That is the concept of mirror reflection, which you have seen before. The moment any mirror is reflected by theta, rotated by theta, the ray which was going like this, now it will go over here. That reflected ray will deflect by 2 theta. Do you remember this formula? Do you remember this concept? Yeah, rotating a mirror by theta deflects the reflected ray by double the angle of rotation. Yep, perfect. So that is why I have put 2 theta over here. So now I think I have made a nice right angled triangle. Okay, where this angle is basically 2 theta, but theta itself is given to me. How much is it? Somewhere it is given. Theta is 30. So 2 theta will be nothing but 60 degree. So 2 theta will be 60 degree since theta itself was 30 degree. This is 50 centimeters. So what will be the height? The height of this will be 50 sine 60, which is 50 root 3 by 2. And this base, and this particular base will be how much? It will be 50 cos 60, which is nothing but 50 multiplied by half, which is nothing but 25 centimeters. So we have found the base and we have found the height, but do not forget our origin is over here. This is our x-axis and obviously this is our y-axis. So all that we have found out is the height and the base. So the coordinates that we need, this is basically the x coordinate and this is basically the y coordinate. Y coordinate is simple. It is still the height only. It is still the height only. So it will be nothing but 50 root 3 by 2. That is your y coordinate. X coordinate will be this minus this. This is nothing but 50 minus this part, which is basically your base, which is 50 minus 25. So that will be nothing but 25 centimeters. So x coordinate is 25, y coordinate is 50 root 3. 50, 25 and yes, just check it out. Where is it? Yeah, 50 root 3 by 2, which is, I think I can just put it as 25 root 3. Perfect. So I think we have got the answer. 25 into 25 root 3. 25 and 25 root 3, which is D option. Perfect. Yeah, done and dusted. So beautiful concept involved over here. First, we found out where the image is formed. Then we found where the next image is formed had the mirror not been tilted. And then I turned the mirror and I use the idea that whenever you tilt a mirror by theta, the reflected ray deflects by 2 theta. So the image would also be formed at an angle of 2 theta from the original reference line. And then you construct geometrically and you will get the answer. Yeah. Perfect, guys. This is amazing, amazing concept. I hope you understood it. Shall we go ahead to the next question? Okay, here we go to the next question coming up on your screen. A plane polarized blue light is incident on a prism that has no reflection from the surface of the prism. Why is that given? We'll think, okay, the angle of deviation of the emergent ray is blah, blah, blah. The angle of minimum deviation for red light is 30. The refractive index of the prism for blue is √3. What is correct among all of them? Oops, this is just the solving slide. Okay, the options are, which of the following statements are correct? Blue light is polarized in the plane of incidence, angle of prism is so and so, refractive index for red light is so and so, the angle of refraction for blue light at the exit plane of the prism is 60 degree. Okay, so many things are there. So let's see what do we do over here. Read the question again. Read the question again. There is a reason why they have given maybe the plane light is incident on the prism in such a way that there is no reflection at all. Why would they give that? See guys, whenever light falls on any refracting medium, it gets partially reflected, partially refracted. Now, if there is no reflection occurring, don't think, sir, this is the concept of total internal reflection. In fact, in total internal reflection, only reflection occurs. Number one. Number two, it happens when the light goes from dense to rare. Here, the medium is from rare to dense, number one. And here, no reflection is occurring, only refraction is occurring. Maybe the idea is somewhere over here, plane polarized light. Now, guess what? There is a law called as Brewster's law, which says that if unpolarized light is falling on a refractive medium at a certain angle, then the light gets polarized, the one which is reflected, okay? The one which is reflected gets polarized. And I think I have put the diagram somewhere, maybe not here. Oh yeah, over here. Perfect. So this is Brewster's law. If unpolarized light falls at a peculiar angle, the refracted light is partially polarized, but the reflected light is 100% polarized. And the polarization is like this. The polarization is basically like this. Now just imagine this was for unpolarized light, which has oscillations in all the directions. Just imagine the light which is falling, has only oscillations in this particular direction, not all the directions, only one peculiar direction. The light which is falling itself is polarized. So when it gets refracted, okay, fine, the refracted light will still be polarized, but the reflected light, it has no component only in this direction, no component of oscillation in this direction. So the reflected light will not have any component at all, because the only component it can have is this kind of oscillations which are in the perpendicular to the plane. So if that perpendicular oscillations are only absent initially, what will get reflected? Nothing will get reflected, so will not have any component of reflection at all. That means this angle of incidence which was there, it was your Brewster's angle. Only for mentioning this part, they have given this data. A plane polarized blue light is incident such that there is no reflection, means that plane of polarization of that blue light is such that the reflections caused are not going to have any components. So all the light will just get refracted, and the angle of incidence for which this can only happen is the Brewster's angle. So very clearly, I can say tan of the Brewster's angle is the refractive index, and I think the refractive index for blue light is given to be √3. So therefore, I can just say that the Brewster angle will be nothing but 60 degree. This is for basically blue light. For blue light, the angle of incidence, this is basically the incidence angle. This is basically the incidence angle. Okay, perfect. So now coming back over here, let us see. Let us draw all these lines. This angle of incidence, we just figured it out over here. What was it? 60 degree. So this was basically 60 degree. This angle over here will be R1. Okay. And the ray will go like that. This angle over here will be R2. And finally, there will be an emergent angle right over here, which will be E. In between, the light will go basically inside, maybe like this. Yeah. And of course, this particular angle which is there, this angle will be the angle of prism. So let's only solve for the blue light right now, only for the blue light. If you look over here, what is the question and what are the options? The blue light is polarized in the plane of incidence. First option, 100% correct. Yeah, this option is 100% correct. And how did I get this particular option? From the Brewster's law. From the Brewster's law. The blue light is polarized in the plane of the figure. Perpendicular components are absent. That is why nothing is getting reflected. So 100%, where is that option gone? Yeah, blue light is polarized in the plane of incidence. Angle of prism, red light, and this is angle of refraction for the blue light in air at the exit plane. So that means exit angle is asked. So these two things are asked. Okay, we'll come to that. First, to find emergent angle, I need A, I need R1, I need also R2. How do I find R1, R2, all these things? Just use Snell's law and all of that. I think that will help us. So let's start with it. First of all, over here, sine of 60 by sine of R1 is refractive index, which is root 3. This is your Snell's law. So sine 60 is a root 3 by 2 into sine of R1 is a root 3. Root 3 cancels. So sine of R1 is basically half. Therefore, R1 is basically 30 degree. R1 is basically 30 degree. Okay. If I get R1, I think I can get R2 also. Now we all know that angle of prism is nothing but R1 plus R2. So therefore, it is 30 plus R2. Therefore, R2 will be nothing but A minus 30 degrees. R2 is nothing but A minus 30. Now again using Snell's law, we can say sine of emergent angle by sine of R2 will be refractive index. So sine of that emergent angle, we do not know. Okay, sine of R2 is nothing but sine of A minus 30 degrees is equal to root 3. Till this point, absolutely clear? Yep. Okay. Perfect. Awesome. Very good. Till this point, absolutely clear, my dear students. Okay. Now, I need to do something about this E, guys. So for that, this delta is given to me. Check this out. This delta is given to me. And delta, I know, is nothing but I plus E minus A. Okay. Delta is 60. Incident angle, I think we wrote it as 60 degree. Emergent angle, I don't know, minus A. So rearranging this, 60-60 cancels. So I am getting E as A. Oh my God. E and A are the same thing. So why not replace this E with A over here? Why not replace this E with A over here? I can immediately get the angle of prism. Is that right? E I have replaced it with A because the deviation angle was given to me. Okay, so now let's proceed. So sine of A is root 3 times sine of A minus 30. Sine of A minus B is nothing but sine A cos B, which is cos 30, minus cos of A, into sine of 30. That's what it is. Okay. Perfect till this point. So let's see what do we get. So root 3 sine of a cos 30 is root 3 by 2 minus cos of a sine 30 is basically half. So that is nothing but sine of a. Okay, so cos a by 2, let me put it over here. Cos of a, the whole thing by 2. Root 3 into root 3 is 3. So 3 by 2 into sine of a. This sine, I bring it over here. So minus sine of a. Okay, so what is the next step? Cos of a by 2. 3 by 2 minus 1 is 1 by 2. So 1 by 2, 1 by 2 times of sine of a. Just check this out. So therefore, cot of a, therefore cot of a, or basically even I can take tan of a, yeah, tan of a is equal to 1. So a is basically 45 degrees. Just check this out. A is basically 45 degrees. Is that right? Uh, just see this. If A is 45 degrees, have we done it properly, everyone? Oh, I think I missed that root 3 while I multiplied over here. So sorry, guys. One second. Sorry, I multiplied root 3 by mistake only in the first term, not in the second term. So sorry, one second. Let me just do it over here. Over here, minus this thing will be cos of a sine 30 is half, and this root 3 will be here, and this sine of a will be as it is. So if I bring this guy over here, so that will be root 3 by 2 cos of a is equal to root 3 into root 3 is 3 by 2 sine of a. This sine a, bring it on the other side, so this will become sine of a. Okay, so this will become root 3 cos a by 2 is equal to 3 by 2 minus 1 is 1 by 2. So 1 by 2 sine of a. So therefore, root 3 will be equal to 2 cancels sine a by cos of a, which is basically tan of a. So if tan of a is root 3, that means a is nothing but 60 degree. So a is 60 degree. So emergent angle is also 60 degree. Emergent angle is also 60 degree. So let's see whether we have got at least few options. The angle of the prism, by mistake I had put 45 degree. Wrong. No, it is not. Refractive index red light, will figure it out. Angle of refraction for blue light in air at the exit plane, that means emergent angle is 60 degree. That is definitely correct. We just got it right over here. Angle of emergence is 60 degree for blue color of light. Perfect. This is done. Okay. Now comes the red light part. Now comes the red light part. So let's solve it for the red color. Now, irrespective of whether it is red or whatever, we know one thing, angle of prism is 60 degree. Refractive index, we don't know. And it is also given for red color, the minimum deviation is 30 degree. Minimum deviation is basically 30 degree. Delta minimum is basically 30 degree. Okay, so I think there is a direct formula for refractive index which we can directly use. Mu is equal to sine of a plus delta minimum by 2 by sine of nothing but a by 2. So this will be nothing but sine of angle of prism 60 plus minimum deviation by 2 by sine of a, which is nothing but 60, the whole thing by 2. So that will be nothing but sine of 90 by 2, which is sine of 45, and this is nothing but sine of 30. Sine 45 is 1 by root 2, sine 30 is half, so it will become 2 by root 2, which is again root 2. So the refractive index for the red color is going to be root 2. Yes, definitely for the red color it is root 2. Perfectly fine. So A, C and D should be correct. Let's see. Yes, A, C and D options are the right answers. Very good. Perfect. Okay. Very good. Excellent, guys. Shall we go ahead to the next question coming up on your screen? Now, there are three glass cylinders of equal heights and the same refractive index which are placed on a horizontal surface as shown. in the figure. The cylinder has a flat top cylinder, okay, has a convex top, and cylinder 3 has a concave top. The radii of curvature of the two curved tops are how much? If H1, H2, H3 are the apparent depths at a point on the bottom of the three cylinders respectively, the correct statements is R. Okay. So how do we do this particular question? Think about it. There are three marks at the bottom of the cylinders. One is a flat surface, one is this, one is this. Question is, what is the apparent depths? What is the apparent depths? And which of them are correct? Okay. Which of them are correct? See guys, first part is very simple. First part is very simple for this guy. If you talk about, if I have, no, I don't have anything. Let me just create a duplicate. This is your normal flat surface. So this point X will come over here. So the apparent depth in the first case, H1, that H1 will be the original height divided by mu. Directly you can say for a flat surface, the original height is it given somewhere? Yeah, 30 centimeters. Original height is 30 centimeters and mu is 1.5. So 15 twos are, so this will become 20 centimeters. So H1 is 20 centimeters. Is it there somewhere? No, it is not there anywhere. Okay, fine. No issues. Now for the second part and the third part, use curved surface refraction formula. That's all that you have to use. So this, treat it like an object. This X, you treat it like an object. This is your curved surface. This is also your curved surface that will have some radius of curvature, which is basically 3 meters. That will also have some radius of curvature, which is 3 meters. And find where the image will be formed in either of the case. Which formula will you use? Mu2 by V minus mu1 by U is equal to mu2 minus mu1 divided by R. See, X is the object, so light is going from here to here. So obviously light, when it is going from here to here, light is going from here to here. This will be the positive side. This will be the negative side. Okay. In both the cases, the object distance will be negative 30 centimeters. The refractive index will be of the glass, which is 1.5. This will be 1. And these two also, you know, R will depend. For the second scenario, it will be negative 3 meters, or for the second, for the third diagram, it will be on the positive side, so it will be plus 3 meters. So accordingly, you will get two values, V2 and V3. This V2 and V3 will give you height 2 and height 3. Will give you height 2 and height 3. Understood? Just use curved surface refraction formula. That's all. I think I would have kept some solution over here. Yes, same thing. First time it is 300, next time it is minus 300. So remember that is in meters. So make sure you convert that meters into centimeters. Yeah, this is in meters. So you have to convert it into centimeters. Minus 300 centimeters. Last time it will be plus 300 centimeters. So that is what you will have to convert it into. That's it. You will get two images, and accordingly you will be able to mark the correct answers. Yeah. Where is it? Where did it go? This one. This one. First height you get 20.68. Remember before H1 was 20. So you will get it as 20.68, and the last one you will get it as 19.35. Yeah. So this is the maximum height. This is medium. This is the least apparent depth. That's all you have to do. Cool, guys. Perfecto. Yep. Amazing, amazing, amazing. Let's go to the next question coming up on your screen. Three plane mirrors form an equilateral triangle, each with side length L. There is a small hole over here, as you can see, at a distance L more than 0, okay? And light is passing through it at an angle theta and can only come out through that same hole because everything else is plane mirrors, okay? It's like your kaleidoscope. Light is coming from one side and there are three plane mirrors at forming an equilateral triangle. The cross section of the mirror configuration and the ray lie in a straight plane. Okay, so it's not like the ray is going here and coming out of the plane or something like that. It's all in the same plane. The questions are as follows. The ray of light will come out for theta is equal to 30. If there is L is equal to L by 2, ray will come after 2 reflections. Ray will never come out for 60. Ray will come out for 60 if this is the case. So I think some scenarios are mentioned. So let's try to treat each scenario differently. What is the first scenario? Theta is basically 30 degree. The ray will come out for theta is equal to 30 for some length between maximum length. Okay. So if it is 30 degree, very interesting thing, guys. If this particular theta, what we are talking about, if this is 30 degree, how will that light go? First of all, realize this is an equilateral triangle, so this is going to be 60 degree. So what will happen to the ray of light? Yep, this will go like this. It will fall over here. So what will happen to that ray of light? So let me draw a perpendicular over here. Okay, if this is 60, obviously this is 30 degree because they are opposite angles. Yeah, opposite angles. Okay, this is 30, this is 60. How much will this be? Oh my God, this is 90 degrees, guys. This is coming out to be 90 degree. What does it mean if it is 90? That means that itself is the normal. That itself is the normal. Oh, so if it is falling normally, normal incidence, this is normal incidence, this is just by that special case. So the ray after reflection will go back via the same path and it will come out from the hole. So definitely it will come out, it will definitely come out of that particular hole after reflection. So what is that statement saying? The ray of light will come out for theta is equal to 30 degrees for some hole which is there on that side. Definitely it will come out, guys. Definitely it will come out. So this L is between 0 and capital N. Definitely it will come out. Everybody fine till this point? Yep. Okay. Very good. Now let's go to the second option. What is the second option telling us? Second option is telling us for L is equal to L by 2, the ray of light will come out after 2 reflections. There is an angle for L is equal to L by 2. So L by 2 means it is exactly in the middle. So forget this. So somewhere in the middle. So this hole is not there over here. Maybe it is somewhere over here. This continues. This hole is somewhere here. So yeah, how can the light exactly go? I think if it goes here, reflects like this, and then reflects like this, I think it will be able to come out after 2 reflections. So this is the first reflection. This is the second reflection. And that's it. After the second one, it is directly able to come out of it. And when this is happening, all these angles are, by the way, equal. Okay, this is 60, 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 this is 60. All the angles are congruent. All 3 equilateral triangles are formed. So this is also possible. So definitely I can say there is an angle for which this happens, and yes, it is definitely happening. What about 60 degrees and L is equal to L by 3? 60 degrees and L is equal to L by 3. Okay. L is equal to 1/3. So this is nothing but L by 3, and this is nothing but 60 degrees. Very interesting. What do you think will happen at this particular angle? Come on, think about it. What do you think will it do at this particular angle? When that light definitely will enter somewhere, let's say like this. 60 degrees is a lot of angle. It will go like this. What will be the incident angle over here? What will be the incident angle over here? Let's think, guys. If this is 60 degrees, obviously this is 60 degrees. This is also 60 degrees. If this is 60, this is 60. This has to be 60 degrees. If this is 60 degrees, then after reflection, the light should definitely become parallel over here. Yep, because this is 30, so this will be 30. Just check this out. Is this making sense? This will be 30. This will be also 30 degrees each. And these two lines will be parallel to each other. These two lines will be parallel to each other. So even this will be L by 3, I believe. Even this much part will be L by 3. Yeah, like that. And after reflection, what will happen? Again, yep, this will go and meet over here. Perfect. And even this much distance will be L by 3. I am seeing some kind of symmetry. And after hitting here, what will that light do? Think about it. This light will go over here. This light will go over here. And this distance, again, I feel will be L by 3. And after reflection, again, it is going to become parallel. Oh my God, some crazy thing is happening over here. And after reflection over here, it will rebound here. Is that right? Yep. It will rebound over here. And I think that was given something over here. The ray of light will never come out for theta is equal to 60 and L is equal to L by 3. L is equal to L by 3. So it is going like this and eventually it is reaching over here. Just check this out. Just check this out over here. Interesting. Yeah, it is definitely coming out. And what does it say? The ray will never come out for theta is equal to 60 degree and L is equal to L by 3. No, this is definitely wrong. It is definitely coming out. It is definitely uh, coming out. It is definitely coming out, as you can see over here. One, so it reflects here, reflects here, reflects here, reflects here, reflects here, and finally it is coming out. Can you see that, guys? Yes, it is definitely able to come out over here. So I'll just mention that word. Yes, it is definitely coming out. It is definitely coming out. So that option definitely is wrong. It will never come out. The ray of light will come out for theta is equal to 60 degree, 0 less than L by 2 after 6 reflections. This is definitely something very weird. Somewhere after 6 reflections, no. Is it 6 reflections? Just check it out. Let's count it, guys. Let's count the number of reflections. First reflection, second reflection, third reflection, fourth reflection, 5 reflections. So it is coming out after 5 reflections. So it definitely comes out, the right will come out somewhere in between. In fact, this L is L by 3, which is less than L by 2. But this word is wrong. It should be 5. It should be 5. So this D option is also definitely incorrect. So A and B seem to be the right answer. Yes, A and B are the correct answer. Beautiful question, isn't it? Yeah. So although it comes out over here, but it is not coming out after 6 reflections, it is coming out after 5 reflections. That's what we saw. Beautiful. Amazing. Yeah, that was the last question which I had to discuss. I hope you enjoyed the discussion. We had some really incredible questions, very, very different kind of questions, all unique questions I have kept. And any more questions which will be required, I will also try to put it up in the PDF so that you can practice it as additional problems. Okay. So God bless you all. All the very best. Keep attending all these advanced classes and make sure you're smashing the like button and also subscribing to the Vedantu J English channel. Okay. Anything else that you want? Any specific requirement regarding JEE Advanced, please let me know in the comment section below. And please remember, there is a special JEE Advanced batch available, which is called as the Ekalavya batch, through which we produce all our toppers. That is still available for 5,000 rupees. Complete assignment, complete personal attention with the complete different set of faculties. Those are the Ekalavya teachers with Ekalavya modules and personalized attention with doubt solving. It's available in pure English. It's there for 5,000 rupees. The link is there in the description box in case you have not yet noticed. Yeah, as you are watching this video, it's there right in the description box of this particular video. Yep, the JEE Advanced Ekalavya batch. So this is a specialized advanced program. You are getting the rank accelerator books, DPPs, everything. Okay, so please check it out. And if you have not yet started your preparation for JEE Advanced, this is the batch which will help you out. Okay, bye bye. Take care. Have a great time.